Hi guys, today uh, I will be studying together with you guys the tree data structures in JavaScript. I started reading about this a couple of days back and thought of making a video. So it is a big topic and would like some patience from my audience and myself also to go through it. I was rushing so that I can make video, but took me time because of some events in life. Okay, so let's get started. Understanding trees in JavaScript. So contents will be I will introduce you about the trees and myself also. The key terminologies in tree data structure, what is required and to know and what is not. Types of trees, basic operations on trees. Okay, and as in future I will be making videos more. I will be adding more contents to in this slide. Okay, let's start. Okay, so in introduction, what is a tree data structure? Importance of tree in data structure algorithms, hierarchical data structure, non-linear structure compared to arrays and list. Okay, so I was googling about this tree. What is a tree data structure and all. Okay, let's just Google. Uh, okay, so Geeks for Geeks. I see this website is little good. It's easy to handy, and I am not signed in, but I use. So it's a specialized data structure to store data in a hierarchical manner. It is used to organize and store data in computer to be used more effectively. It consists of central nodes, structure nodes, subnodes, which are connected via edges. We can say that tree data structure has root, branches, leaves. Okay, so they have given some cute type of a structure here, which is the root here, edge here. These are the leaf nodes, siblings, and subtree. They call it as a subtree like this. Okay, so from time to time, I refer many of the websites, but this is one of the website which I am currently referring to. So this is a tree data structure. Okay, it's a non-linear, meaning like in arrays and linked lists, one after the other. It is not like that. It is a hierarchy. Like we have a parent, then we have a child, like this kind of things. Okay. I myself have also prepared some of the things, terminologies, but I will come back. So as you were seeing here, some of the terminologies like what is this? These are the like key terminologies which I added also in my video, which is node, root, child, parent, sibling, leaf, edge, height, depth. Okay. So I prepared one like a lucid chart for you. It can be from other websites also, but I prepared one. So here this is the parent node. Okay. They also call it as a root node here, and this parent has two childs. B is a child of A and C is a child of A. Here B and C are siblings. Okay, siblings. In any tree, the nodes which has the same parent are called siblings. Okay, that's why. Okay, so now let me come back to here. Siblings I've told, root I told, node. Node is nothing, just a place here where the edges connect to the node. This is the node which is having kind of a data left and right kind of a pointer here. So this is a node. Okay, and nodes are connected to each other by edges. This is the edge. You see the branches, they call it as an edge. Okay, so node, root, child, parent, sibling I told, leaf node. Let's come back to leaf node. So here are the leaf nodes like D, I, J, F, K, H. So we call the leaf nodes which don't have any children, like those are the last things in the tree. We cannot say E is a leaf node because it has children, it can be further subdivided. Same way for G. That's why we call these things as a leaf node. Okay. Now edge is the branches that connect between the nodes. Those things we call it them edges here. Okay, height and depth. So height is something, height of a tree or between the nodes is the number of edges. Okay, if they say of tree, it is always from the root to the longest or the farthest node leaf node that we calculate if they say about a tree. Same for height and depth. Okay, I hope this diagram might be helpful for you. Okay, these are the terminologies, and same way these people have told it here. Leaf nodes is there, seedlings is here. They are giving more of a, things are here, but we will try to study it together in subsequent videos, step by step. I don't want to get overwhelmed myself and don't want to make audience also. Okay, so this is a simple like a study path which like I am trying to showcase here. Types of trees. Okay, here we have a different types of trees, and I have summarized here some parts of it. So let's see. Binary tree. We have binary search tree, BST, ABL tree, and red black trees. Okay, binary tree I have already googled before this video. Let me share with you guys. You can also read it, like it's a open source and all, so there is nothing hidden or like I'm just storing information on it. Binary tree data structure is a hierarchical data structure in which each node has at most, this point is very important, at most means maximum, two children, referred to as the left child and the right child. It is commonly used in computer science for efficient storage and retrieval of data with various operations such as insertion, deletion, and traversal. Okay, so this is the definition of a binary tree. So I again iterate, it is at most is very important. It can have only two maximum. It can be orphan, it can be one left or only one right, that way. So this is a definition, okay, for the binary tree. I will come back for these because as I mentioned in the starting of the video, this topic is little big, and I just don't want to make it a video in a hurry fashion way, so that people learn nothing out of it. So I don't want that. Okay, now comes the second part, basic operations on trees. Okay, which is insertion, traversal, in order, pre-order, post-order, and deletion. Okay, first we will focus on the insertion. When I say insertion, meaning like how will we create the binary tree. Okay, inserting the data. So one more thing I would like to mention here, if you see here, just take a word of mouth here, like this is the data one. Okay, one second, one, two, three. No, this is not the right way. Okay. I wanted to show you something. Okay, so this is also another very cute diagram, which is the data left or right. Okay, now I wanted to mention in this uh, tree structure is that if the root value and the new value which I am trying to add, okay, suppose b, it is not present and I'm trying to add on a, if this value is more than a, then it should come on the right side, and if this value is less than a, it should come on the left side. Same goes for the subsequent values. Okay, that's how we store it. I wanted that definition. I will search it, maybe I add it somewhere. Uh, they might have added it somewhere. Okay, I mentioned it like that only. So let's get started. I will do some coding for this for tree. I have created already a folder, tree data structures. Let's see binary tree. Okay, binary tree.js. Okay, yeah. Okay. Now let's create a first. Go back here. So implementation of binary. Let's define the node class first. You see, this is the nodes, and here I was seeing some, yeah, this is the node which has a data left and right. So we will create a, first of all, the node class here. So class node, let constructor here. Okay, and it will have data and left. this is the default value. Okay, and right equals null. Okay, now this dot data. Okay, and that's it. Like we have created the class node here. Very simple way, like data left and right. Okay, here. So left will itself be a node, I know, and that's how that's how I have like created this data section. Now let me write the class. Okay, let me adjust my table 1 second, guys. Okay. Class binary tree, and now add a constructor here. I will just create a non-parameterized constructor. I will mention this root. Okay, it is equals to none. Okay, initially. Now insert operation. Array. Shit. 1 second. Why this is happening? Okay, let me do why this. Insert. Okay, data. This is one method which I am going to create. Binary tree class. Just 1 second, guys. I am going to, okay. Okay. Because we will have to create a new node to store the data, right? So it will create us a blank node. Now I will check if this dot root double equals to null, meaning this is the first time we are adding the data. Then straight away this dot root we will just give it to as new node. Okay, and if this is not the case, then we will else we will call another method, this dot insert. Okay, and this dot root we will pass. Okay, comma the new node. Okay. Now let's define this method also. Let me add it here. Insert node, and this is thrown the error in second because I need to add some node, irrespective it is root or not, but new node like I mentioned. Okay, so node and new node. Okay, if new node, if new node dot data is less than node dot data, which I was mentioning with you guys. Okay, then I will check if my node, which is the parent, okay, here node dot left is double equals to null. Okay, if it is null, straight away add that node dot left is equals to new node. Easy peasy, right? Correct. Now else, if it is not the case, then we will have to iterate it, meaning like we will use recursion. This dot insert node, and now what will happen? Node dot left will become the parent, and we will pass straight away the new node here. Okay. Okay. Now if at all like it is not the case, meaning like our data is greater than, then straight away I will just copy paste it. Okay, instead of writing. Okay, node dot right is null, then right is equals to, then node dot right. Okay, node dot right is equals to new, and that's it. Okay, so So that's it for this like binary tree. Straight away, we just created a very simple. I will just add a placeholder like to do. We will have to do more on like in order, post order, and pre-order. Okay, but for the sake of this video, I just want to you to guys to pause this video, take a screenshot, and use some AI tools to just understand this code. Okay, if it is not the case, then it should be intern for you. The last thing which we should do is let's create a tree. Okay, let tree is equals to new binary. Okay, and now I will use tree dot insert. Okay, and I will use this. Okay, now 5, 3, 7, 1, 4, 6, and 8. Okay, so what will happen? Okay, so 5, 3, 7, 1, 4, 6, 8. Okay, that's how I am inserting the tree. Okay, so let me just write it down for you guys in the lucid. Okay. Mm, okay. So first 5 will come here because we have inserted 5, correct? Now 3 will come. Now 3 is less than 5, so 3 will come here, right? And now we added 7, so it is more than that, so 7 will come here. So 5, 3, 7. Now 1 we are adding. 1 is less than this, 1 is less than 3, so it will come like this. Okay, 1, and I hope you are able to see, understand. And then I will add 4, so it is less than 5 but greater than 3, so this value should come here. Okay, now 4 will come here. Okay, now 6 and 8. 6 is more than this but it is less than 7, so uh, 6 will come here. Let me just give some space. Okay, in this sequence. Yeah, so 6 will come here, and 8, so it is more than 7, so it will come here. Okay, that's how like our tree will be created or added. Okay, I think I had some yeah, so here we added 5, 3, 7, 1, 4, 6, 8. So this is one kind of tree visualizer. I found it online, it's free. You added values, how you enter it, submit input binary tree, and that's how it created. The same we created 5, 3, 1, 4. You see 5, 3, 1, 4, 7, 6, 8, and the same thing 7, 6, 8. Okay, I'm not drawing the arrow, but let's add it. Okay, now hopefully this branch is also you will be able to grasp and understand. Okay, yeah, this is the binary tree we have created. Next topic which I will be covering will be to the traversal in order. Okay, in order, pre-order, and post-order. Okay, and then deletion. After that we will go to the understanding of trees like binary search tree, AVL tree, red flag tree. Okay, I hope this video found you in good shape and helpful in your journey. Uh, and apologies guys, I was little late to upload it, but it should be up and running from now.